Hello everyone, myself Sasireka, Academic Coordinator, Department of Computer Science, Artificial Intelligence and Data Science. Let us discuss about the estimation of software process. The current organizational landscape is scrutinized, identifying areas ripe for enhancement. Objectives are meticulously outlined and the scope of the process introduction is defined. The subsequent phase pivots towards education and training, a cornerstone for successful implementation. Team members partake in comprehensive workshops, immersing themselves in principles, practices, and tools associated with the chosen methodology. Refinement and documentation represent a pivotal stage encapsulating insights garnered from the pilot project. Feedback is systematically analyzed, refining the process to a mature state. Documentation meticulously crafted ensures clarity and accessibility to all the stakeholders, serving as a guiding background for the implementation. Techniques. The first one is expert judgment. In this technique, the group of experts in the relevant field estimates the project size based on their experience and expertise. This technique is often used when there is a limited information available about the project. Unlocks estimation. This technique involves estimating the project size based on the similarities between the current project and previously completed projects. This technique is useful when historical data is available for similar projects. Third one is bottom-up estimation. In this technique, the project is divided into smaller modules or tasks and each can be estimated separately. These estimates are aggregated to arrive at the overall project estimate. 3-point estimation. This technique involves estimating the project size using three values: optimistic, pessimistic, and most likely. These values are often then used to calculate the expected project size using the formula such as PERT formula. Next one is function points. This technique involves estimating the project size based on the functionally provided by the software. Function points consider factors such as input, output, inquiries, and files to arrive the project size estimate. Use case points. This involves estimating the project size based on the number of use cases that the software must support. Use case points consider factors such as complexity of each use case and number of factors involved and the number of use cases. The next one is parametric metric estimation. For precise size estimation, mathematical models founded on the project parameters and historical data are used. COCOMO model. It is an algorithmic model that estimates effort, time, and cost for the software development projects by taking into account the number of different elements. Wideband Delphi consensus based on the estimating method for balanced size estimation that combines expert estimates from anonymous experts with the cooperative conservations. Monte Claro simulation. This techniques, which works especially well for complicated and unpredictable projects, estimates project size, analyzes hazards using the statistical methods and random sampling. Importance of the estimation. Resource allocation. Appropriate distribution of financial and human resources ensured by the accurate estimation. Risk management. Early risk assessment helps with mitigation techniques by taking into account complexity of the project. Time management facilitates the creation of realistic schedules and milestones for the efficient time management. Next one is cost control budgeting. Both the terms are closely related, which lowers the possibility as cost overruns. Resource allocation enables the efficient task delegation and work allocation optimization. Scope definition defines the scope of the project, keeps project boundaries intact, and guards against the scope creep. Estimating the size of the project. Lines of code. Number of entities in the ER diagram, total number of procedural data flow diagram, function points, a line of codes. As the name suggests, LOC counts the total number of lines of the source code in a project. The unit of LOC, KLOC 1000 lines of code, NLOC non-comment lines of code, KDSI thousands of delivered source instruction. The size is estimated by comparing it with the existing system of the same kind. The expert user predict the required size, various components of the software, and then added to total size. Advantages: universally accepted, and it is used to mainly models like COCOMA. Estimation is closer to developer perspective. Both people throughput utilize and accept it. All at the project completion, LOC is usually quantified. It has a specific connection to the result, simple to use. Drawbacks: different programming languages contain different number of lines. No proper industry standard exists for this technique. Number of entities in the diagram. ER model provides the static view of the project. It describes the entities and their relationship. The number of entities ER can be used to measure the estimation size of the project. Advantages: size estimation can be done during the initial stage of the planning. The number of entities is independent to the program technologies used. Drawbacks: no fixed standard exists. Some entities contribute more to the project size than the others. Just like FPA, it is less used to cost estimation model, hence it must be converted to LOC. Total number of processes in detailed data flow diagram. A data flow diagram represents the functional view of the software. The model depicts the main process or functions involved in the software and the flow of data between them. Advantages: it is independent of the programming language. Each major process can be decomposed into smaller process. This will increase the accuracy of the estimation. Drawback: studying similar kinds of processes to estimate size takes additional time to effort. All software projects are not required to be construction DFD. Functional point analysis. In this method, the number of type functions supported by the software are utilized and find FPC, that is function point count. The steps in functional point analysis are: count the number of functions of each proposed type, compute the unadjusted function points, find the total degree influence, compute value adjusted factor, find the function point count.